It's a good thing.
Reed keeps wanting to retake it, but only so that he can get a better score than Jackson.
I feel like a really good score.
Huh? Reed? Yeah, he got
There we go.
like a 32.
Yeah.
But Jackson got like a 34. So.
Well, darn it. Yeah, I don't know.
That would be a good basically.
I also went to River Falls. I don't know. Anyway, it really just depends on what college you try to go to. Okay. So moving on.
That's why I'm going to art school.
And if you want like scholarships or not, I don't know. Anyway, okay. You're all worth it. Don't worry about
Thank you, Maggie.
it. Yeah. You will make it.
So I'm simultaneously worth
Call me up. I'll help you out.
and deserve to
Alright.
be judged by Stella.
Yeah, you can be worth it and also be judged by me.
You're worthy of being judged.
You're worthy of being judged.
Oh
and
man,
going
that's a
to
good one. All right, so today we're going to do a law of sines. Yay! It's going to be a bunch of proportions. So if you remember proportions and cross multiplying, whoo, today's your day. All right. Or if you're like Lex and hate them, then today's not your day. Alrighty, so here we are. Turns out that the formula we're going to have, which is already on your formula sheet, is that sine of the angle A over the opposite side, which is side A, is going to equal sine of angle B over its side B. Okay, so if you didn't know, and hopefully I talked about it in geometry, but here you go. If you were talking about any triangle or any shape, the opposite side of it is labeled its lowercase. Okay, so intersections or points are always capital letters, and sides are always lowercase letters, if you didn't see that pattern. Okay?
I feel like you learned that in geometry.
Yeah, see? And so then if this is capital B, then this side is B, and if this is capital C, then this side is C, which is kind of hard to get capital and lower, but there you go. So that's the idea, and so when you set up all of these proportions, it turns out they're true. How nice is that? And it's not the angle over the side, it's sine of the angle over the side. But we're gonna end up solving these. So yay. Okay. And again, that formula is on your formula sheets, and so therefore will be, but again, probably not hard to remember. Right? Okay, but maybe. All right, so here we go. If you remember back to, again, geometry, solving a triangle just means the things that aren't given, find them all, okay? So, for instance, C is not given, B is not given, capital C, capital B is given because it's 48. So each of those pieces are what you're trying to find, all right? But they only give you some of the pieces to work with. You'll notice that as much as we are using trig, which is sine, this is not a right triangle. That's okay, okay? The law of sines, which we're doing today, and then the law of cosines, which we'll be doing tomorrow, is applicable to non-right triangles. Yeah, huh? We've gone out of the right triangle hole, and we are now in every triangle.
But hypotenuse.
Well, there is no hypotenuse.
Yeah, but sine is opposite over.
Sine is the link between sides and angles. So that's what we're using it as. All right. So in this case, if I want to find side B, for instance, how would I set that up? I know side A, so sine of 36, and I know side A's length, which is 8. But in side B, or angle B, I only know the angle, but I don't know the side length. But that's okay, because if you have 3 of the pieces of your proportion, then you can get the missing piece.
Yeah.
So every time that you do one of these, you will always be given one angle and one side of either A, B, or C that you have both of. Because if you don't have an opposite one to match up, then you don't have a proportion to actually set up. So you will either be given angle A and side A, or angle B and side B, because you need a proportion or a scale. So then we get to cross multiply and divide. So if you don't remember, you can solve this by the fact that the diagonals multiplied equal each other. And so if we multiply sine of 48 in degree mode times 8, and then divide that by sine of 36 in degree mode, we should get some measurement of B, which is going to be great. Times 8. Divided by sine of 36. Great, it's 10.1145. Doesn't really say what to round to, so I like lots of decimals. So this is 10.1145. All right, but now we can use that proportion if we wanted to then find the rest of it. However, usually using the answer that you came up with is not necessarily the best in the next step, because sometimes you have the incorrect answer, and so therefore, whoops. You do not need law of sines to get the angle of C, however. What do I know the angle of C to be?
It'd be 180 minus
There you go.
36 minus 48.
Yes, so you could take away 36 and take away 48, and oh my gosh, we have some number. 84, so 96. There you go, 96. So again, not a 90-degree angle, which we knew, okay? Because I said that law of sines can happen for any type of triangle. So 96 degrees, so we know that. So now we can change this to be sine of 96 for the C angle, and then we can find the C side from that. Same idea, we're going to cross multiply, so sine of 96 times 8, yep. And that result divided by sine of 36. Woo. And so now we know that the length of C happens to be 13.5359. Alrighty. So again, when we solve, you're finding every single missing piece. And so angle C in this case, length C and length B. Alrighty. So questions on that so far? Excellente. Let's see what's next. That can't be it. Alrighty, there we are. So the last one we were given 2 angles. This one we're given 2 sides and an angle. So we're not going to be able to right away add up all the angles and see what is missing to make 180. So now we just have a lot of side lengths. So we have, for instance, angle A and side A again. So we already know that the proportion we're going to use is going to be sine of 26.3 degrees over 7. That's one of the proportions that you'll use to find your missing pieces every time. And so let's say that we want to find B, because we can't really do C. I cannot at this exact moment find any of the C measurements because I don't have enough information. You can't have 2 variables to solve your proportion. So if you felt like doing C, too bad, you're going to have to wait a little bit. All right, so then you're going to get B and 6. So now we're going to cross multiply. Sine of 26.3 times 6 divided by 7. And kind of awkwardly, we're going to get 3798 equal to the sine of B. Okay, because I'm not going to say that the degree measure is 0.37, right? That's not possible, really. So what do I do to get actual B?
Wait, yeah.
You have to do an inverse.
Yes, there you go, the inverse of sine.
Oh, it's actually called inverse.
Yeah.
Okay.
So we do the sine inverse of this side, and that will give us our actual degree, because this will cancel the sines, so you get B equals whatever that number is. Which, yeah,
Sine 26.3, you take that times 6, right?
divided by 7.
I
Yep.
thought it was 7 divided by that number.
No, it's the result of that multiplying divided by 7.
Oh.
Yeah, that'll make a different number. All right, so, and you always want to keep the decimal as long as possible, so don't just type 0.3798 because you're going to have some slight error. So anyway, 22.3198 is your degrees. That's an 8, not a 1. All right. So now, because we know that this degree measure is 22-ish, we can take that idea of the sum of a triangle is 180 and get the missing C value so that we can do the other side length. So if we have 26.3 plus the previous number, and then we take that away from 180, we have 131. So 131.3802 degrees. Don't have to be that specific, but anyway. So hopefully you're not rounding to whole numbers, okay? Just whoa, all right? Especially in the middle of a problem, let's not do that. I know, but it's so wrong. So we're gonna do the ratio of the C values. So this is gonna be 131.3802. And then this bottom part is C. We don't know what it is yet. This one you will not have to do sine inverse. Remember that the only time you ever use sine, cosine, or tangent inverse is if you are finding an angle, which is what we did last time, so that's why we use sine inverse. But this time we're finding a side length, so we won't need any inverses at all. So we just do sine of this large degree times 7 divided by the sine of 26.3, and we should apparently get the long side length. I'm going to do that. Sine of 131.3802 times 7 divided by sine of 26.3. So apparently that's 11.8545. And just so that we know that we are doing something slightly correct, remember that in a triangle, the opposite angle and the side have a relationship. So for instance, if this is the largest angle, the largest side length should be over there. So if I got 5 point something as the length of this, I probably did the math wrong, okay? Because the largest angle should have the largest side across from it. And then the second largest angle should have the second largest side across from it. And the smallest and the smallest. So kind of a way to check yourself at the end a little bit, other than the answer key.
How did you get that? Because if I did the sine 131 times 7 divided by the thing, and I got like 0 point something.
Did you press enter in the middle of it? Because you can't do it all in one. You have to do sine of the 100 and whatever times 7, enter, and then divide by sine of 26.3.
We can get that, and then you multiply by 7, right?
Sine of 131.3802 times 7, yep.
Yeah, and then you like 5.25, and if you divide
Yep.
that.
By sine of 26.3, I got 11.85.
Oh, okay. I must have messed up.
Whatever. Winners, there it is. Alrighty, maybe. Alrighty, then we got this guy. Oh, this is the special case that I hate. Okay, so here we go. So, sometimes, depending on what kind of triangle they're giving you, well, first of all, it could not exist, but moving on from that, it could also, based on only the pieces they give you, actually form two triangles. So, if the angle that is given is adjacent to the a longer side, and opposite is shorter than the longer side, you can in fact swing that side in and make an obtuse triangle versus an acute triangle.
But I want a cute triangle.
I know, I love acute triangles. So if you are ever set up where the angle that is given, its adjacent side is longer than the side they give you, you have two cases, and so you get to solve two problems. Yay!
Wow!
Get to or have to?
You get to. Duh. So,
But does it have to?
yes.
Okay. Just checking.
You will have two sets of answers. Because you either have the one that I outlined in green up here, the whole triangle, or you have this little guy over here, which is also a triangle, okay? Don't forget about him. And again, that's because the angle is next to the longer side than the one that they gave you. Okay. So again, if this was 5 and that was 6, this is not the case. Because you need the longer side next to the angle that's given.
But could you just do it the other? Oh, no, because you've done the 3.
Yeah.
Is it always going to show the dotted line to show us that there's a triangle there?
No.
Okay. So
It will instead just give you this statement. And as you make it, you're going to have to see that the
so
angle
how
is
do we
next to
know
it.
if the longer side is with the angle, then it's...
Well, because when you draw this, not given that, you're going to draw any triangle, doesn't matter. And across from A is going to be your 6. And then this angle is 30. And then it doesn't matter if you put B here or B here. because the adjacent side will have to be 7. And so if this side next to that angle is bigger than the opposite one that was given, then you have to make the 2 triangles. So if I put B here, which I did, and C here, that is true still. The adjacent side is bigger than the opposite side of the angle.
Another question.
Why
does it make 2 right triangles? What's up with that line?
Oh, that's just them. Ignore that. That's just them.
Like, yeah, I get it's the height of the
Talking
triangle.
about it,
but
swinging
why would
it.
Show
It is neither here nor there. Yeah.
Cool.
Sorry.
Okay.
They put that in for fun. Okay. Just to know that there's a height of triangles. Oh, let's actually solve this. Okay.
That would be
So remember that you have 2 sets of answers now. So we're gonna call this one, because we're not using those letters, X, and this is triangle Y, okay? So let's go ahead and solve triangle X. Okay, so here we go. Triangle X has a sine of A over its side length of 6. Sorry, I gotta put the actual A in there. And then we are given, I know, huh? That the side length of angle B is 7, but we don't know what B is. All right, there it is. And what's going to happen is, if we get an acute angle, that is this triangle. And if we get an obtuse angle, notice that would be this triangle. And if we don't get either of them, well, then I'll tell you how to get it. So, sine of B, I assume we'll get the acute angle. Here we go. Sine of 30 times 7 divided by 6. Okay, I didn't close the parentheses. That's going to be a problem. Okay. I'm sorry.
Okay, I love you.
Thank you. Okay. Yes, that's right. Hello. So we're getting 0.583 repeated, which is lovely, except that equals sine of B. So we need to actually get B by taking the inverse of everything.
Whoa.
Yeah. So sine inverse of the decimal you got, and then sine inverse of the side with the B leaves the B. And we now have whatever that is, sine inverse of the decimal. 35.6853. So that means that of triangle X, we have just found angle B. We're coming over to it. There it is.
Sick.
All right, thanks.
Yeah.
Okay, and I'm going to write it in here small, even though that's not ideal. Okay. So then, if we kind of look at how this goes, and maybe this is where the height comes into play. If we say that this has a 6 here, and a 6 here, if I swing it in, right, that's 6 as well. If this is 35.68, what is this base angle? Yeah, because it's an isosceles triangle. So if this is also just this little piece, 35.68, what would be this angle of angle Y then? Right, if 35 of it is there, but it's a linear pair with another angle.
180 minus that.
Yeah, so then the other angle B is 180 minus it.
That sucks.
I'm sorry.
Okay.
So every time that you find that first angle,
Yeah.
to get the opposite angle of the second triangle, 180 minus it. They're a linear pair. I know, huh? Because we know it had to be obtuse, so it couldn't be 90 minus that. But anyway, so this angle B on a triangle Y is 144.3145, because I subtracted from 180. So the original angle B was 35, but its like sister angle is 144. Or brother, or sibling.
Thank you, Maggie, for keeping it neutral and all inclusive.
I try. All right, so then we're going to add 30 to that and then see how far we are away from 180, because hey. So that means that this tiny little angle, because it is tiny, is 5.6853 degrees. That's okay, because it is a very small angle based on the fact that that one was so big. It took up a lot. And then, because again, a triangle has 180, if this is 30 and that's 35-ish, then we have something else to make 180 from that. 0.6853. Oops, that's not what I want to do. 180 minus that. So 114 is this angle measure, 114.3147. So all I did was use the law of sines to get the one angle, and then all of those angles should add up to 180. And then to get the second triangle's angle, we subtracted from 180 and then also found its missing piece. So honestly, now that we have every single angle, we should be able to find every single side very easily. Okay. Melvin to the front of it. All right. So for instance, in triangle X, all right, we are missing side length C. So we're going to use angle 114.3147 and side length C. And now we can find out what that longer side length is. Because in the other triangle, triangle Y, it should be less than 7. But in this one, it should be bigger than 7. So sine of that number times 6 divided by sine of 30 leaves us with a missing piece of 10.93. So C is 10.9356. So we have every single side length, 7, 6, and 10, and every single angle. And so that's solved. We just need the one missing side length of Y. And we can get that by using this teeny tiny angle measure of 5.68, but still the same ratio of sine of 30 over 6 and sine of 5.68 over C. Because it's the same ratio, because it's the same angles and sides, but this one happens to have an angle of 5 instead of 114. A lot. So sine of that small number, 5.6, I did 6.5, 5.6, 853 times 6 divided by sine of 30. Lots of signs going on today. All right. Oh my God. All right, so side C is 1.1888 units. We don't have any measurements on this, so sorry about that. All right. So I hate it just as much as you do, but there are two triangles here, and we had to solve both of them. So every angle and every side length. On your test for this, there will be a little blank spot for every single one of them to write in, so it's not like you will just draw arrows like I did, okay? So that's that. All right. I can't remember if there are any more examples, so hey, let's see. Ooh, yeah, a little application example. Ooh, look, only odds, okay. So let's apply this, because you never know when you're going to have a telephone pole and some shadows, you know?
You're very true.
Yeah. I mean, sometimes I'm just like, look at that telephone pole shadow. Okay.
Have to find out now.
I need to know how tall it is, just for life reasons. Okay. So, oh my God, that's a really weird diagram. So here we go. A road slopes 10 degrees above the horizontal, okay, meaning across, and a vertical telephone pole stands beside the road. So in case you're wondering, that means there's a right triangle. Okay. The angle of elevation of the sun is 62 degrees. Thank you. That's where this is coming in, apparently. And then that would also be down here. The pole casts a 14.5-foot shadow downhill along the road, and we need to find the height of the telephone pole. Jeez Louise. Okay. So lots of stuff happening here. Let me just take a minute to double check. I don't know why that thing is like coming at us and not at the side.
I don't, the physics.
Really
Right, like I would have drawn it this way.
The
Like
physics
why?
and also the art is bad.
Right? Yeah.
But
So-
it's the math.
So I assume the 10 is in there for a reason.
It has to be.
Because why is it might not be.
It's two triangles. Are they just trying to mess with us?
I think they're trying to do a
Yeah.
design thing.
I think it's trying to mess with us.
Well, you don't have enough information.
Yeah, well, yeah, we do because of the law of science. Anyway, so
The laws
like
of science. Like,
law of sine.
oh, the law. That makes more sense.
Yeah, it does.
Yeah.
Well, we have a right triangle, so I don't know why it would matter at that point.
Oh,
Hmm.
we don't have any sidelines. I think that's
Yeah, I don't, we have one side length.
Yeah, because don't we know that it's
No.
14.5 foot shadow?
Yeah, the bottom.
So we know C.
And yeah,
Mm-hmm. And we have the side length next to it, next to the angle that we have. But we should have something. Oh, the sun. No, and 10. 10's not
The
helpful.
10-degree aspect of somewhere.
Because yeah, otherwise we don't have any
Is it
the
information.
slope of the road.
Are you sure the 62 is not the 10 and the top angle is not the 62?
Yes.
Because then you would actually be able to do something.
Well, no, because
Oh,
like it
because
says
of,
the
like,
road
vertical
slopes
angles or
10 degrees
something?
above horizontal, so it wouldn't. The 10
Well, this
would
would
be
be
up at the top.
62 as well, because it's
The 10 has to be
vertical
somewhere.
angle.
Yeah, the 10 is the bottom, but is the 10.
So that's
And then that's a right
10.
angle, so you can do it all based off of that.
And this is a right angle.
Yeah.
And that's 10 degrees
90
here.
degrees. So we already have all this in. We have all the guts.
So we have 110 right here then? Oh,
What?
110, sorry, 100. I can add 90
I
plus
thought
10.
it was a right triangle.
But because
Not-
the road's at a
Because
slope.
the road
It's
is,
at a 10-degree slope.
yeah, it's at a right angle here with the road, but if we take out the road, then
Gross.
it's 90 plus 10.
But is the slope above horizontal? So yeah, it would be 100.
100 there. And so then is
Okay.
62 here then as well?
It would have to be.
Because otherwise we don't
How
have
does
it.
math work?
I don't know how math works. That
Mhm.
isn't how math works.
Because it's got to be 180.
Yeah, I forgot.
62 minus 180.
160
162.
minus
180 minus
100.
62, so
18.
18.
for this measure up there. So we should be able to find the height of it by using law of sines and 62 and 18,
Yeah.
right? 18, yeah, because of the opposite. So we should get sine of 18, because that's this one across from its side. And then that's going to equal, we want the side across from 62. So sine of 62 over x. And so we don't really need the 100, but we kind of do in order to get the 18. So, yay! And then we cross multiply and divide, and hopefully we know how tall an actual one should be so that we can see if our answer makes any sense in the realm of life. How tall would you say a telephone pole is in general?
Approximately 41 feet.
Oh, I haven't checked
Oh, is that because that's what you got?
Oh, that's funny. What did I say?
Yeah, 41 feet.
Yeah, approximately.
I don't know, the telephone pole by my house is
It's a little tall.
That's really tall.
taller than the 2-story house that I have, so
This
I
is
don't
a
know.
4-story telephone
Bigger
pole.
than 20 feet? Wow. Anyway.
My telephone pole is actually shorter than my house because the squirrels in our house would use it to jump. Okay, the squirrels were in our house because they would use the telephone pole and the trees to jump onto our roof and then nuzzle and get into our roof.
So your house was taller than your telephone pole?
Maybe.
Oh.
We have a 3-story house.
Oh, okay. Yeah. Oh, well, excuse me.
Okay, a duplex. It's not a good house.
Okay. Sounds good. All right. So moving on. That was that. Oh, and we solved it, and that's why we were guessing that it was 40 feet because it said 41.43 feet. Yeah. I mean, I'd say that's a telephone pole, that's for sure. Well, that was a really interesting diagram. Okay. Anyway, it turns out that these are the exact examples in the book as well. So if you check in your book, this one is worked through as well, and it should be there. So you can double check that work there. Other than that, we have our assignment. So woohoo, that I will totally put the answer key on HeadBrush right now so that I don't do what I did last time. So here we are, odds only of 1 through 21, 27 through 37, and 45. You are gonna have to be drawing a bunch of triangles. And make sure you are wary of is the angle adjacent to a side longer than the other side length given, because that's the two types of triangles. The two answer triangles.
How many prosecutors are there?
One more, I believe.
Oh, yeah,
I
yeah.
like what you said.
It uses law of cosines next, I believe.
Oh,
Ah,
You know, to go with sines. There is no law of tangent, don't look it up.
that's good.
It's just,
you said that sounded like you were covering it up. There was no law tangent.
don't even think, I actually don't know, I'm sure there is.
There once was, but it's forbidden now.
We've burned it. Yep, it's in the forbidden section. Okay. Little Harry Potter reference there.
Yeah,